Okay, welcome. Thanks for watching. This is going to be a quick tutorial on a Parallax robot with an Arduino Uno. I've added a sonar detector, distance finder, and a Eeprom memory chip. So what we're going to do with the robot is try to avoid obstacles and sort of detect the distance of things. And here are all the links to SparkFun, which is pretty much where you can buy all these electronics and their product number. Okay, so let's get this video started here real quick. Sort of a grainy video, shot it on my cell phone camera, and basically what you're going to watch here is this robot go around the room. I've created a small track and I've taped it off with some painter's tape just to keep the robot from wandering all over my house, which is a mess. But basically what we're doing with this robot is we're adding sort of a right wall following mouse maze algorithm to the Arduino Uno chip, and we're basically telling it every time it comes into a certain distance of an obstacle to turn to the left, and it's basically going to follow the perimeter of the room on its right hand side and go around the perimeter of the room, avoiding these obstacles. So one of the things that we do with this is, and if you look on the right, we have a picture of a breakout board that's mounted on the front of the robot, and the breakout board has the Eeprom memory chip, and it has the distance detector, which is the sonar component. And the sonar component is actually really easy to integrate into the circuit. It really only has 3 lines. It has a power, a ground, and a analog signal, so you can sort of detect the volume of the electrical current on that particular line. And then the other component we have is an Eeprom memory chip. It's quite a large chip for such a small little piece of equipment, but one thing to point out here, which is why I have this picture, is there's a pull-up resistor on the clock line. That's quite important, otherwise you could have some problems wiring that chip up. And the other side of the chip pretty much just all goes to ground. And again, the robot is just sort of going to go around the room a couple of times. And so here's a close-up, and I think you can really get this assembly drawing off the internet with those links that I showed at the beginning of the video. And here's a picture of the top of the robot. So we're kind of getting into the code now, which is always important. And I do have a picture of the AT Mega, which is the sort of the brain of the Arduino Uno, and it's always helpful to know what pins you're dealing with, specifically in this setup routine when we're initializing the infrared sensors, which basically tell you if there's an object in a particular range. It doesn't tell you how far that object is from the sensor. But again, it's always important to go from, say, that previous slide of the shield to the actual AT Mega drawing itself, so when you're looking at the data sheet, it can all kind of come together when you're initializing things like the infrared sensors. And I'm initializing the serial line so I can do some debugging, and you also want to initialize the wire.begin, and that's for the I2C protocol that you're going to use with the Eeprom chip. Again, more code here. One of the unique things I want to point out here on the left, besides all the includes that you're bringing in, is the device address under the settings label. You'll see it's set at 50 hex. That tells you what the Eeprom chip is identified as on your circuit, so when you're communicating with it, you have a defined address that you can use. And then on the right is pretty much just directly out of the manufacturer's website / data sheet. It tells you how to use their sonar distance detector, and this is how you pretty much read the analog pin signal and figure out how far away something is. This is the Eeprom chip that we were talking about earlier. You know, on the left here we have the functions that we're using to write to the Eeprom chip. Again, with an I2C or an I2C protocol. And then on the the functions are all pretty much self-explanatory. On the right here, we do actually have a picture of the chip that we're using, and again, everything on the left-hand side of the chip pretty much goes to ground, and on the right side, you have your clock, your data, and on the data line, you want to make sure you have that pull-up resistor. And then on the figure on the bottom there, again, most of the stuff comes out of the data sheet, is the actual sequence that you need to send for a control byte. And remember that device address is 50 hex based on how you wire up this Eeprom chip so you can communicate with it and send it information to remember. So what we're actually sending to the Eeprom chip is this is sort of the brain of the program. What we're doing here is sort of adjusting the robot when it comes into certain conditions, and so you sort of elaborate through those conditions and you know, tell it to turn left if it meets a certain condition, or adjust right. And most importantly, when we're doing this, every time we make a move, we want to store that move to the Eeprom chip. So we could, if we wanted to write a more complex algorithm, we could do a recursive step and step through the memory of that robot and send it back through the course the way it came, which we didn't really get into for this particular algorithm. But you know, again, what we're doing here is adjusting the robot to certain conditions, and we're storing a memory of what that robot did for later use. And I'll post all the code on my 1990s blog. Thanks for watching. Cheers.